Well, welcome everybody to another Training Tuesday. It seems like we've been doing this for 5 years now, but it's only been for a little over a year and a half. Today we have someone special with us. Actually, the person that trained me and taught me a little bit about how to do these Training Tuesdays. And the very first class that I taught was an IML show that's coming up, and it was how to keep your door hardware code compliant. We have done this class in the past, but I thought that having Bob do it would give a little bit of an extra special touch on the course. Bob has been doing this for, I think, a little over 30 years. He's great at what he does. He brings a lot of excitement to his classes. And if you know Bob or have been a part of any of his trainings, you know that he is great at what he does. So without further ado, I'm going to hand it over to Bob, but I would like to ask, a couple things about the presentation. We're going to keep the mics muted until we have a segue. If you have any questions, please put them in the chat, and I'll either answer them in the chat window, or we'll ask Bob during a segue what you have, and we'll allow him to answer you directly. We'll also be unmuting some of the mics to allow you guys to ask any questions that you may have on various codes that have to deal with architectural openings. So Bob, why don't you take it away?
Great. Thanks, Justin. I appreciate that. I mean, as much as we talk about this industry and how long we've been a part of the industry, one of our goals is to keep it simple, to keep it smart, to keep it secure. We're going to kind of give you a little bit about the company, Dormica, and kind of our vision, our mission. Ultimately, we need to provide an opening that's safe and secure. When I talk about safe, we both have to be able to get out. And the new one that we haven't seen any codes that really affects this yet, but we could because of that is the healthy part of our door openings, and how do we get less transfer of communicable diseases and COVID and viruses and bacteria and things of that sort. And so that's kind of that new next talk point that's there. But we want to keep it as simple as possible. I like to say that I've got an hour to teach you everything I know about codes, but the reality is I've probably forgotten even some of the parts of the codes. I've been doing this we like to term our training team, or what we call learning leaders in our organization. We talk about how many decades we've been doing it, and everybody on our team's been doing it at least 2, 3, or 4 decades as far as door hardware is concerned. And so I kind of grew up in the industry. My dad was in the industry, but I wasn't going to be in the industry. And so I got my engineering degree and worked for a facility as a facility engineer for about 8 or 9 years before I actually stepped into the world of hardware. And it was by default that I ended up at this. The recession hit in the late 80s, and I came to work, or I applied for a company that manufactured exit devices. And so even though I grew up in doors and hardware with my father as a kid doing it while I was in high school and college and kind of helping out, if I throw that experience on and that knowledge on it, that's that 50 plus years of experience. It's a part of that. My most recent one, just to kind of give you a little heads up, we continue to learn things. I recently received a gold badge from NFPA, National Fire Prevention Association, as it relates to the fire door inspections. I teach that class, and so that's another one that if you're interested or whatever, we can communicate to Justin and the team, and we'd be more than happy to give that one out. That's my information that's there. As much as I go by Bob, it's formerly Robert, so if you need to reach out to me for any reason, it's there as well. And if you'd like a copy of the presentation, we'll be more than happy to deliver you an electronic version of that. Our company covers a lot of different areas of the industry. Today, we're going to be talking about particularly the doors in the path of egress and our fire doors that are around our facility, because that's the codes that comply to those. We became part of the Dormica family, let's see, I was going to say a couple of years ago, but it's been about 4 years ago now, in July of 2017. And in doing so, it just kind of brought this world of products even larger. So today, our corporate headquarters that we call the Dormica USA calls headquarters is in Indianapolis. where we manufacture the exit devices, the door closers, the lock sets, the keys and cores. And we're truly doing manufacturing. We've also expanded and brought in some of the other products that Dorma and Caba have to be in that same house, in that same area, and utilizing the engineering teams and the leadership teams that are there. So it's really been an interesting adventure, needless to say, in the last few years for our organization. And some of the things you're going to start to see are some branding changes. So I'm not going to go into a lot of detail, but you'll start to see a branding category of Best. You're going to start to see a branding category of Dormica, and then a branding category of Design Hardware. In all of these categories, there are ANSI Grade 1 products. It's just that the products that we have are going to be positioned to be more resistant to the daily uses that you would see in an education, healthcare, government environment, as opposed to a product that might be maybe something that's not going to be quite as vulnerable in the Dormica branding and in the Design Hardware. So that's something you can look forward to in the future. This program is an AIA program, so in doing this, we have to meet the requirements that they have. This is a little explanation of what the course description is. This is what you're going to be walking away with, and basically it's going to be understanding the codes that come into play for our door hardware. And the reason we call this how to keep your door hardware code compliant is because of the fact that as much as our facilities were originally designed with these codes in mind and the efforts of these codes to be a part of our building, unfortunately, what ends up happening is these codes don't get upheld. We let our hardware go. We don't fix it until it breaks. And sometimes we have problems. Now, hardware, in the world of mechanical items, things break. But we have a responsibility to make sure that our hardware is still kept up to compliance. And so one of the things that we talk about is what are these codes and why do we have them? And this is why we have them. People look to the U.S., they look to the American standards that we have within our building and construction industry. Even though we call it the International Building Code, they look to us for guidance and directive. So we're really ahead of the curve, and we kind of have had this most significant influence on the codes. But if you go into other worlds, other parts of the world, this is a dilemma. So why is this a problem? Why isn't this okay? It says this is the fire exit. Well, no, we assume that first off, you can read this. Second is you can swim. And third is, you got to hope and pray that you can get to a safe spot. That's not the way our codes are. The way our codes are designed is to get you out of the building, and it's really without the need of a special tool or special knowledge or any special effort. And so we keep that at the premise. When we do everything in our industry, everything is built around getting you out of the building safely. So when we secure a door, it should only be secured from one side, which is the outside, but still provide that egress to get us out of the building. So it's an important part that we make sure that we do that. In doing this, we're even going to talk about later in the presentation some things that deal with the electronics for access control as it relates to our buildings, because so often we have integrators that are brought into a facility afterwards, and we're asked to equip a door, or they're asked to equip a door up with access control. But one of the things that we can sometimes forget is requesting to make sure that they keep it code compliant. And the reason is because they can come in and work on what is a fire rated door, but they may compromise that opening or the integrity of that opening by removing hardware and putting on new hardware that's on it, or maybe not having the positive latching that we need that's required by NFPA. So we'll talk about those as well. Excuse me. Fighting the seasonal allergies, if you will. So I'll ask for forgiveness early on. So the things that we have to deal with are the International Building Code that you see right here, but also local codes. And a lot of times we emphasize the point that a local code can be more restricted than the building code or the International Building Code. These documents are really, we take when we're building a new building, we have to submit this to the State Department of Buildings. And in those organizations then have to give the blessing and make sure we're compliant to it. Within those are going to be things that we call life safety codes. Those are going to be NFPA 101. That's the code that applies most there. Fire code, NFPA 80. Smoke codes, NFPA 105. Accessibility codes, American with Disabilities are ANSI 117. And then we'll talk a little bit about energy codes. They're starting to come up, become more common, and so we'll make you aware of that. And then the security requirements, meaning what can we do on doors with electrification for products that may delay people from exiting or our access control to still make sure we comply to the codes that are there. So we have security codes as well. So we'll cover all of those. When we're sitting down with an architect or an engineer as a consultant, we need things. We need information. And the more information we get will allow us to make the specification package or the door hardware package consistent with the requirements of the code. So we have to have the fire life safety plans. We have to have the occupancy plans for the facilities. I started to do a class on what are occupancies and what are they listing and and it was really boring. I mean, and so I'm still trying to figure out a way that I can incorporate that into a class, because a lot of times people ask us, what is the classification? What are the difference in classifications? It's not something we decide. It's something that's deemed onto that building for that, or particularly maybe even a use of part of a building based on, is it for assembly? Is it for education? Is it for healthcare? If it's for institutional, there's just all these different categories that are there. But for the most part, the codes are very similar. And so we'll talk about the safe way to review a code as it relates to that. Then we also have to have floor plans and door schedules and door frames. We've got to make sure the hardware that's being used can be put on that particular door. There are different varying hardware, and we'll try to talk about that a little bit. And then we'll look at some special security requirements, and again, that becomes an important part. And then one of the big ones that we spend a lot of time on is American with Disabilities, handicap accessibility requirements. And then last but not least, when we're dealing with the architectural world, the design criteria and the finishes are an extremely important part that plays into that as well. So as a hardware consultant, some of the things are that classification occupancy. We need to know that up front. The occupant load, I'm going to show you how it's calculated, but it used to be just a sign on a room. Today it's done a little different. So we'll talk about that. We want to make sure that the path of getting us out of the building is unobstructed, that we're not going to have any sort of inconveniences or things that are going to block our way. But those are the things that we have to make sure that we keep our hardware code compliant by making sure that somebody doesn't move something into the area, start to store something in the area that would block our ability to get out of the building. And then we constantly are working with fire doors and smoke rated doors that we have within our facility and keeping them intact. It's critical because they're part of a protection barrier built into the original design of the building so that the fire doesn't get transferred from one part of the building to another. And it's a segregation, if you will, between the areas of the building. And so it's important that we keep them at the utmost operational mode that's required there. And in any sort of facilities or where we hold doors back, or make them a part of that, where they're a part of the emergency evacuation system, but they need to now be able to be released and closed onto the opening. So it's an important part of that as well. Security, we already kind of talked about it, but we have to make sure that it doesn't interfere with that fire life safety requirements as well. So we can do it. There's a lot that we can do here. It's just that we have to make sure that we think and choose the appropriate solutions that don't interfere with that. And so often the integrators are not well versed on the codes. And so what ends up happening is they're the one that's out there that's compromising the opening, not intentionally, for their benefit, but a lot of times they're not familiar with this. And then the doors and frames, obviously, one of the problems that we see in the field is contractors sometimes just don't hang doors right, or they put the wrong doors into the wrong openings. And sometimes that, all of a sudden now we're trying to put hardware on a door, it doesn't seem like it fits. And so we have to stop and ask those questions to make sure that it's being done right. So when we look at that life safety plan, one of the things they talk about is our path of egress. And in this particular just example, you see, we've got some arrows here that indicate the maximum distance of to exit discharge, and that's kind of how they term this opening right here. It's putting me into that emergency stairwell. The maximum distance that you'll have to travel from this point, this farthest point here, is 168 feet. Now, normally we're going to see some each state varies a little bit on this, but for the most part, it's usually under 200 feet. It's I think the last time I saw for particularly in Kentucky, I think it was like 185 feet. I'm coming to you from Louisville, Kentucky today. That's where I occupy my time when I'm not on the road training. But ultimately, what this does is we have to look at this room and say, what is some of the materials or the equipment that we're going to have in this area, and then we have to make sure that we know what that path is. So I always like to tell people when you're in a hallway and you have doors that open, what we call double egress, they open in both directions at that opening. What ends up happening is you're at probably the farthest point you can be from an emergency exit, because that was probably put there because of the travel distance and the separation requirements that are there. But it also allows us to go both ways. Some people don't know this, but if you look at a set of doors and they swing away from you, that's the direction you need to head to get out of the building. And you'll have exit signs and maybe some directional information that's there. But if you're in a pair of doors that goes double egress, where they both open opposite to each other, then we can go in either direction from that point to get out of the building. So it's just one of those little inherent little things we learn over the course of time as we're working with buildings. There are a bunch of different doors that are out there, and so often these doors might be on we may see this many doors on a project, and unfortunately sometimes mistakes occur. So we're constantly working in a project to make sure that the appropriate doors are put on the appropriate frames. And it's not uncommon for us to see the incorrect doors put in, and sometimes even the frames are hung wrong and the doors don't swing in the right direction. And so it's a critical component, but again, we try to transfer that information as well. I like to always tell you that the problems that we run into with hardware on a project are the same problems that we're seeking information for when we start to do a door schedule. So door schedules, occupant loads, varying, net versus gross, I'm going to explain that. Door widths, door heights, that sort of thing, where it varies in the applications. These same problems that are the information we're designing off a drawing also end up to raise their ugly heads in the field because of the problems. Now, this is just during the normal construction, trying to build this building from new. Can you imagine that what can happen is when we're out in the field and somebody starts to have hardware issues, have door issues, have damage that occurs at the opening, they go and put door and hardware back in place, but excuse me, but they may not be doing it correctly. So it's important that you understand what the codes are that are in place. The International Code Council, or what we call the International Building Code, has a great site for this. If you go to their website, and if you click on the state, it'll pop up and it'll tell you what the current codes are that are in effect for your local state. As well as sometimes it'll even drill it down to the metropolis areas or even cities and tell you what codes are in effect. Well, a lot of times what we find, with the exception of just a very few states, most of the time states are at least one revision back. So if the International Building Code today is 2018 and the most current one, we may go back to 2012 possibly for the adoption for that particular state. It's not a significant difference, but it just means that we may not have the most current code being applied in our area. Normally, we don't see any more than 2 revisions away by a particular state. So in that particular case, I think 2008 or 2009 was the previous code adoption or one that was before that. So today, if you were working with the codes, most of the facilities you're going to work with would either been under the 2009, 2012, or 2018 as it relates to the codes. But it's important that you know where they are and what the state's requirements are. And you may have a city within a state that has adopted something newer. But for the most cases, most cities kind of conform to whatever the state adoption is as it relates to that. So it's a good place to go. What we tell people all the time is you may not be aware of all the codes that come into play for your hardware that we use within the facility, and this is the codes that we have to adapt to. There's some additional ones that are specific to some ANSI standards that we may have to do for the exit devices or for the door closers or for the lock sets that are separately, and that's as a manufacturer we have to make sure that we comply to those. But our building codes that we have to work with are the international building codes. So today it would be IBC 2018. Within that code, it's going to have reference to the fire code, the life safety code, the smoke codes. It'll have references to these NFPA 252 or UL 10C. This is testing protocol that we have to pass with our products to make sure that they adhere to the testing requirements that are part of that. And usually you're going to see some sort of listing that would carry that and support that. Within the life safety code, there's a couple of different ones. We're going to focus on NFPA 101, but there's also an NFPA 5000. Today, there's also an NFPA 3000 that is probably the most current one or the fastest one that ever came about, and that's for intruder or active shooter preparedness for your facility. And so it's another one you may hear a little bit more about in the conversations that are going around. And then American with Disabilities, we all know it is ADA, but it does have a standard, and it's ANSI A117.1. And so that standard now makes it a requirement for our building construction, renovations, whatever it might be, that we adhere to and adopt to those. And some of those things will affect our door hardware. Some of those things may affect your outside of your building, your access to your building, which would be curbing and parking and ramps and things of that sort as well. And then a lot of these things are supported by the door hardware industry, or DHI. And those are door functions and things that are part of that. So there's some manuals or references that are in there as well. And then that ASHRAE, that energy code, is the one down here. We'll just kind of touch on that one towards the end. So when we're dealing with fire doors, in particular NFPA 80, when it comes to our swinging doors and frames, they're going to be in fire walls, and the fire walls are going to have a different rating than the fire doors. And I always like to say this is in the early part of my learning when I was starting to get into the industry. And even though I'd worked on doors and hardware as a kid growing up, I never really asked those questions. I just did what I was supposed to do. You go hang this, go do this, go file that strike. Yeah, I'm guilty. I followed a strike when I shouldn't have, but I didn't know it at the time, and I was directed by my father to do it. So we've done some things that are wrong in the industry. But fire doors and fire walls have different ratings. And I asked an older gentleman in the industry a number of years ago, I said, why is it that a fire door doesn't have the same rating as the fire wall it's in? And his answer was because a wall is a wall and a door is a door. And I was waiting, and he wasn't going to give me any more definition. And then I had to ask, so can you help me here? And he said, a wall is intended to be a wall. So it's going to have combustible materials, and it's going to have furnishings and things of that sort up next to that. And it has to defend against that additional fuel that's going to be part of that fire. A door is intended to be a door. And so when we go through the door, we walk through the door, there's nothing around the door. There's no furnishings on the door. The doors aren't designed to have combustibles in front of it. So it doesn't have to follow the same protocol because it's not going to have the combustible materials are there. Now, I can tell you, I've been involved in a number of different fire tests for hardware, and a 3-hour fire test is a long time. There's a lot of snap, crackling, and popping, and we're not talking Rice Krispies here. I mean, it is the hardest test that we have today to pass. So if you have a product that's rated for 3 hours, that's the most durable and the highest rated that you can have in an opening. keep in mind that the lowest rated component on a fire door opening is the highest rating that door opening is going to have. So if somebody happens to put hardware that's 3 hours on a fire rated wood door that's only an hour and a half, even though I could be in a metal frame that's rated for 3 hours, my maximum rating because of that door is an hour and a half. Similarly, we'd look at the hardware too, but most of the hardware, mechanical hardware you're going to see today has been rated up to 3 hours. So if I put a 3-hour rated hardware on an hour and a half required wall, I still have the meeting of the hour and a half rating that's there. So it's an important part of it. Also, when we're dealing with steel doors, the Steel Door Institute has a great support website that's out there to help you select, and they've got some really good learning modules that are out there for steel doors. But in the world of steel doors, if the steel door company follows the SDI standards, then they're approved for anybody's hardware that's approved for the test. So in other words, when we as a manufacturer go to fire test our hardware, we put it on a door and a frame that they tell us specifically to put it on. If we pass the test on that door and that frame, we're approved for everybody's doors and frames that meet the SDI standards. So it's nice that it's there. Unfortunately, that doesn't exist for wood doors, because wood door companies, there's a lot of smaller ones that are out there. Even though they might use the same materials and the cores and things for their doors that other companies would do, their design criteria, their prepping, their manufacturing of those doors vary. So you have to go to each one of those door companies and figure out what they're approved for and what they're listed for. Now, we don't, with the exception of concealed vertical rod and a design change that we might do, hardware that goes into those is consistent whether it's a metal door or wood door. Exception is concealed vertical rods. They do vary by the company, so you'll need to check with the wood door companies for that. This is going to be kind of how the reference goes in the manual today. Excuse me, but we're going to give you some boxes here, and the boxes are going to indicate where this information comes from. Like you see here, International Building Code 2018, it's in 716.2 for fire door assemblies. That used to be in 2012, 715.4. So we use that as a reference because as much as we'd feel honored that you would say, hey, Justin or Bob gave me some information about fire codes and it was this, it's really more creditable to that person you're telling them if you say in NFPA 80 in section 7.1.4 it states this, right? This is the document. You can get that information online. You don't have to buy the manual. I've got them because I use them, and they're portable and I can carry them with me, but you can find that information today online, and you can get that supporting information you need. So you're going to see references on those slides as we go through this that will direct you in there as it relates to that. In addition to that, NFPA 105, we'll talk a little bit about smoke seals and gaskets, but ultimately, the smoke is the leading killer of deaths in a fire. It's not the fire itself consuming someone, but it's the smoke. So we're starting to see a more of an influence of seals and smoke seals and gaskets for doors. Not all doors are required to have it. The underside, and a little bit later, I've got a slide that supports it. The underside or undercut, I just got that question posed to me this week, does not require a smoke seal or gasket unless it's some sort of pressurized chamber or area that would have the requirement. So I'll show you that as well as it relates to that. We talked a little bit about occupancy. Okay, so the rating is established by the state, but then our room size and our capacity of our room is established by our square footage. And so what ends up happening is when we start to look at our areas or our situations that we're working with, we have to work with what we call gross area versus net area. And basically the difference between the two is any item that is not a movable item that occupies space in the room, i.e. cabinetry that you might see, and this is the lighter areas or the dotted areas that are here on this right side. Because that's not occupiable space, we don't have to include it into it. In this particular case, this is a very large conference room table that's not intended to be movable. So we can reduce our net square footage by deducting that. You look at this area over here, and it's got a lot of portable tables that are in here. Because they're portable, we now have to consider that usable space. So what we would do is we'd take the square footage of the room, and then we'd subtract any sort of immovable object, and then we would take that and we'd divide it by a certain number. Now, depending on the number that we divide it on will depend on what our occupancy rating is. There's two numbers that we tend to see getting used. 3 square foot per person, that would be a room that could be used for reception, kind of a stand-up type environment. And then 7 square foot per person, which would be more of an office kind of environment, classroom environment, where we're going to have desks and chairs, and we're going to be spread out a little bit more. COVID, unfortunately, hasn't changed our occupancy level, if you will, that we can have in a room, but we've changed that. So our room itself can still occupy the same amount of people based on the 3 or the 7. I always teach that we should use the 3 because it's probably the safest one. It's going to tell us the most people that we'd be having a room. Now, from that information, it's going to define a few things. One is it's going to define which way our doors swing. So once we exceed 49 people, our doors are going to have to swing out. And then it's also going at that point probably going to cause us to have a hardware on our door that's going to be exit hardware. So it would be like a panic device would be on the door. It would no longer be a lock set that's on the door. So under 49, we could go away with a lock set. We could have the door swing in. We wouldn't have to have the door swing out. But once we exceed that 49, get to the 50, excuse me, now we're going to have doors that have to swing out and swing in the direction. That could be important, particularly if you're trying to keep your door hardware compliant, because you change the capacity or the use of the room. And let's say we had a big office, storage, whatever it might be, area. Now we're going to make it more of a community room, and we're going to have more people in there, and we're going to do presentations or whatever the case might be. Now that door might have to be redirected and swing in the opposite direction. You'll never get in trouble by having an exit device on a door that doesn't require it, but you will be in trouble if you don't have an exit device on a door that requires it. So it's an important part to keep in mind. And so that area or that occupancy of the room can be defined, or defines which way our door swings, what sort of hardware we have to have, and then how many doors we need on a facility. But that's usually taken care of you more in advance. So in this particular case, 2 of these areas may not have been an area that would individually require us to have doors that swing out. But because we have a movable wall here, we have to look at this whole area as the grouping area, and now that changes the complexity of that opening. So it's an important part of it. Long gone are the days when they used to put a sign up that would just say 98. Now, I throw that number out because it used to be, and I'll show it to you here in a few slides, but it used to be in the documents where 50 was our magic number. Anything 50 or above, doors had to swing in the outward direction, and we had to have exit devices up. Then it went to 100. So you see why people are putting signs up that said 98, because it just kept them under that threshold. Now it went back for certain occupancies back to 50. So for the safety sake, always use 3 square foot per person, and then always use the number of 50. Once you're at the 50 mark, you're going to be required to have exit hardware on the doors. The other things that get into play are the life safety parts. And so when we start to look at a door and we start to look at its operation, what ends up happening is we're only allowed to have one operation to operate a door. So it's going to be an exit device or a mortise lock, or as you see over here, we see this quite frequently where we'll see a deadbolt and a cylindrical lock, but we can't do that because that would require 2 operations. There are products that are out there called an interconnected lock that has a deadbolt function, but it's connected on the inside. So when I operate the lever from the inside, it retracts both the deadbolt and the latch that's on it. So keep that in mind. If you're looking for that added level of security, there are products that are out there. You just got to make sure you choose the right product when it comes to that. And when we talked about the exit devices and the requirements for assembly and educational occupancy and in healthcare occupancy, that load is 50 or more. And so it's always going to be a part of that. Also, if you think about why we have why you see exit devices more in hallways than you do in let's say a classroom or a room environment. It's because the room may only go up to 25, but if I have 4 rooms that are in this section of the building, that's now 100 people that are going to be in the hallway. Now the doors that we encounter to go out are all going to have to be equipped with exit devices, and it's for the purposes of getting more people safely through a set of doors more efficiently than it would with a traditional lock set. So the exit device part, the push bar part, has to be at least 50% of the opening to meet those requirements. And we put these on doors what we call means of egress, and it basically says it's a continuous or unobstructed way of travel from any point in a building or structure to a public way. So that's going to be discharge where we can scatter into a parking lot or outside of the building. So any doors we encounter up to there will require us to have the exit device on it. We have 2 types, fire rated and non-fire rated, because we're going to encounter some areas of the building that were part of a wall separation in a path of egress, and it's going to require us to have fire rated components that are on the door. When we get to other parts of the building, maybe exterior doors, those are not fire rated in most cases. And so that would only require us to have what we call panic exit hardware on those particular openings. Now, this is just kind of show you where the International Building Code changed. So back in 2000 and up to, well, back prior to 2000, we were at 50. That magic number was 50. In 2000 and in 2003 code books, it went up to 100. In 2006 and up to current now, it dropped back to 50 in educational and assembly. So you see there's kind of some confusion that we've had in the code books, what was what or what. And I always say err on the side of caution, which means we're going to talk about the number being 50 as opposed to 100, and then that just safely brings us into play. And then for NFPA, they've always had kind of that 100 number, NFPA, excuse me, 101, but we still, again, because of the international building codes, we want to make sure it's more stringent than the other one. So we want to make sure we comply. When you're using hardware or panic hardware, the push bar area has to be 50% of the width of the door. So if you're going to put an exit device on a door, and the door is 48 inches, we need an exit device that has at least a 24-inch push bar area. If the door was 36 inches, that push bar area needs to be about 18 inches. Maybe it could be more, but it can't be less than that. And that's for the purposes, again, we get to the door, let's say the room that we have a smoke-filled hallway, we can't see. We know that at this particular point, when we come up to the door, it's going to be easy to find the hardware that operates the door as opposed to trying to reach for it. Other areas that you might see some interesting concepts are surface bolts or what we call unequal leaves, where we have pairs of doors, but we only have one door that's needed for the access. We only have one door that's needed for the egress purposes, but we might have another panel that's in the opening for bringing equipment through and things of that sort. So we're allowed to use approved automatic flush bolts on these applications and where we have those. Now, the hardware can't be present on the other leaf. So if you notice here on the picture, we have hardware on the right panel, but on the left panel, there's no hardware. That's to indicate, here's your door. This is the one you should be operating. In addition to that, we want to make sure that the flush bolts, again, are automatic, which means we're going to have some sort of coordinator to make sure that this panel closes first before what we call the active panel would close. And so it's an important part of equipping that door appropriately. It's not just when we choose to have automatic flush bolts, it's not just the flush bolts, but we're going to need a coordinator as well, particularly if we have an opening that has some sort of fire rating or smoke requirement. And then manual flush bolts, it says they're not permitted, but there's always these exceptions to the rules. And usually when we see these out in the field on these applications, it's because it's like a patient room door where the leaf is not needed for occupancy or clear opening width or whatever it might be, but it's intended for just so we can open the door and and bring equipment through and things of that sort. So keep in mind where you're going to be seeing those. So a little confusing because they're both flush boats, but one is manual and the other is automatic, and that's the significant difference between the two. Now, when we start to get into stairwells that we have to deal with, let's say our building is above 4 floors, so we're going to have stairwells that we need for emergency exits. In buildings that have this requirement of a stairwell, we have to provide the ability to re-enter the building from the stairwell in an emergency situation. And so often an integrator will come in and put an electric strike in, but unfortunately the electric strike doesn't provide that positive latching that we need in the event that there's an emergency. Let's say we're using an electric strike for access control. When we cut the power to the electric strike releases. Or let's say when we cut the power to the electric strike secures. So when we send power to it, it unlocks and then it secures itself. Well, in that environment, that's good because it's latched, and that strike probably is, hopefully that electric strike would be fire rated. But the reality is it doesn't allow me to come back in because the locking component or the electronic locking component is the electric strike. So in this particular case, to meet the requirements, you'd have to be looking at hardware that has the electric lock and unlock feature built into it, as opposed to electric strike. So you have to be careful in the stairwells when you get into them, because a lot of times we refit a tenant area, and in this door that provides access to the stairwell, we put some sort of access control on, and we don't think about people are going to be required in the emergency situation for us to re-enter. So the floor itself. If we ever get into a high-rise environment where we're above more than 4 floors, we're not allowed to send anybody further than 4 floors of travel within a stairwell to re-enter a building. So even though if you notice by the design, there's a re-entry point at 10, there's a re-entry point at 5. We've got 1, 2, 3, 4 floors before we could get back in. We can do that, but sometimes we have to equip these buildings or these designs to make sure they accommodate for that, so the travel's not there, and there's specific signage that's required. So if you ever go into a hotel, you're going to see signage in the stairwell that tells you can re-enter at, if I'm on the 6th floor, I'm going to be able to re-enter at the 5th floor, 4th floor. Maybe one of those is not, so it'll tell me 5th floor, 3rd floor, or all the way to it. And sometimes they'll even tell you as an exiting point, it can go to a rooftop or something. Now, to give you an update on some code changes that recently came in, just as a reference, we not too long ago, and when we say that in the hardware world, it's probably meaning something occurred about 10 years ago. When we say not too long ago, this is kind of a slow industry as far as change is concerned and modifications and things of that sort. But we did equip our electrical room, if it's bigger than 6 foot wide, and you can basically occupy inside this room. If there's any sort of overcurrent or electrical voltage going on in this room, if the amperage of that equipment is 1200 amps or more that's in this room, we have to have doors that swing out of the room, kind of like an emergency exit again, that is equipped with panic hardware, which means it's going to have an exit device on it. And that's for the safety of the people who would be in that room. And let's say an arc occurs or there's a flash, spark, that sort of thing. They don't have to contend with trying to open that door towards them to get out. So it's a new requirement that's there. We expect this to change in the next revision to be probably around 600 amps. We've already seen some electrical code changes that dropped their requirement to 800 amps. So we anticipate that they're probably going to change this one as well to 600 amps. So more to come on that one. When we look at doors that are in hallways that swing out, so we kind of mentioned this service room or this area where this equipment is, the door is going to swing out. Well, when we start to have our doors that swing out into the hallway, we have to make sure that we're not going to interfere with people passing through the hallway. So the doors can't take up more than half of the width of the hallway, and they can't extend more than 7 inches off of the wall when the door is fully open or open till its fullest point. That's a part of that. So we have to start looking at, are there ways that we can offset our door openings to make it to where they don't interfere? Because if this door opening up here opened into this hallway and you had this door directly across from it, we would have a problem because these would interfere, cut our hallways down to less than half the width of the hallway. So we have to be careful. When you start to reset your doors, also be careful because there are maneuvering clearances that are required for American with disabilities, both with people from walkers and wheelchairs and crutches, and they all apply. Wheelchairs are only 1/3 of the disability things that we see. The other 2/3 are walkers and crutches, and canes. So you need to keep that in consideration as well. But when we get into these environments, we need to make sure that the door opens appropriately and doesn't interfere. So it's an encroachment area that we talk about as well. And there's some exceptions to those. When we start to look at that American with disabilities, one of the things that you're probably familiar with is that we're not allowed to have tight grasping, tight pinching, twisting of the wrist to operate. Now, I will tell you this, we have had discussions about keys, but keys are not a public tool, if you will. In other words, when we're doing a public facility, making sure it meets American with disabilities, we intend for these doors to be unlocked and operational so that they can operate with the lever. What we don't do is when we give you a key, it becomes more private. So there are some things that the industry does with like large bow keys and things of that sort. But ultimately, because the key is not a fixed part of the lock, it's not considered to be an ADA issue. It's the operational hardware that we have to make sure that complies with that part of it, as well as we have to make sure our clear opening width is appropriate. That number in the US is 32 inches. I say that because we have Canada and theirs is slightly different than ours. And then there's other countries that have these similar barrier-free requirements. But with us, everything is measured from the face of the door to the face of the frame when the door is open to 90 degrees. Even though that door in the picture could possibly be pushed back to 180 degrees of opening, we can't take it to that point because an individual wouldn't push the door that far. In addition to that, if we had an automatic operator or a power assist on this door, it would only open the door to about 90 degrees. So that's where we have to measure our clear opening width. I'm going to show you that we can have hardware on the door. It's just a matter of where we locate the hardware that we don't have to take it into consideration for this 32 inches of clear opening width. So importance is if you have an opening that's not quite 32 inches, you might want to consider swing clear hinges. That'll pick you up about an inch, inch and a half over here. That might be all you need. In older facilities, this is a concern. In newer facilities today, we've standardized on 36-inch doors, swinging with traditional standard hinges. We still get our 32 plus inches that we need for that clear opening. But when we're looking at sliding doors, accordion doors, pass-throughs, we still are required to meet the requirements of that 32 inches. If we have a pair of doors and this pair of doors are providing access, I can only consider one door or the other of the pair for my clear opening width for meeting the 32 inches. Even though we might have two 24-inch panels, and if you opened them, you'd have almost 48 inches. The problem is, unless there's something there to open the door, both doors exactly at the same time, I can't consider this opening meeting the requirements for American with Disabilities. So if I'm manually going to be walking through these doors, one leaf on this opening has to achieve the 32 inches of clear opening. So what we see in our door applications today that are out there is unequal pairs where we have a small leaf and a large leaf and we indicate that that's there, or they'll come in and they'll retrofit this up with a fixed panel that's over here, and now this door on this side would be that 36-inch door or 42, whatever it might be that needs to be the requirement. So if both doors don't open by one operation, I have to look at each door individually and make sure that one of the two is at least 32 inches, and then whichever one it is, let's say we get it with one and not the other, we have to identify that that's the active door and that's where the people, and that's our handicap access is through those. The one that we probably have the least information about in the field, but it becomes the most critical, is we have what we call maneuvering clearances that are required to operate a door. And depending on where you are on this, it may require more or less space than what you than one versus another. And what I'm referring to is, if I have a door closer at the top of the door, I'm going to need more maneuvering clearance than if I don't have a door closer. And if you think about that, when somebody operates the door and they open the door starts to close on them if they have a door closer, and so it requires a little bit more maneuvering area that would be required to manage that particular door. There's about 6 different pages of this information available on ada.gov. If you go to their website and you do a little search, you'll be able to find more details on the maneuvering clearances. Now, again, if I equip this with an automatic operator and I have the door open for the person by a waving of the hand or a touching of a button, or even approaching the door with some overhead sensor that would detect that they're there, I don't have to have these maneuvering clearances, because now that door is open for me and I can travel through that door. So sometimes automatic operators bring us that. We talked about where you can have hardware on a door. As long as I mount my hardware above 34 inches, I'm okay. I will emphasize this: manufacturers tell you where to mount the hardware, and where they're telling you to mount the hardware is meeting the requirements of American with Disabilities. So if you choose to relocate the hardware, normally on an exit device or a lock set, it's going to be about 40 inches off the finished floor. If you choose to lower that hardware, it could be a problem. Okay, so keep that in mind. But hardware that's mounted between 34 and up to 80 inches, if it's operational hardware, it has to be within 48 inches of the floor itself. That will not interfere with our clear opening requirement. What will interfere with our clear opening requirement is on the push side of the door, the bottom 10 inches needs to be free and clear of any sort of obstruction. Imagine, if you will, that when somebody goes through with a walker, they're going to use that walker to open that door and kind of manipulate that door as they progress through. If you have vertical rods on your door that go down and latch at the bottom of the door, it could interfere and cause a trip point or an impediment for them to get through the door. So the bottom 10 inches needs to be smooth and clear on doors. Now, we have less bottom rod applications for like vertical rod applications, but if somebody has a kick down stop on a excuse me, on a single door, that kick down stop will be an impediment if it's in that bottom 10 inches. Also, other things like automatic door bottoms and things of that sort can interfere with the bottom of the door. Now, I will show you that there are some guards and things that are out there, but even this, as much as you think it would meet the requirements, doesn't, because it's not a continuous smooth surface from this edge here all the way out to this high point. You see there's this transition that occurs here. Same with the rod guard and latch guard that's down here. They don't meet the requirements. We do get questions about kick plates. And if the kick plate is thicker than 1/8 of an inch, it's required to have some sort of cap at the top of it. So if you have a molded door, a paneled door, and you have a kick plate on it, and the kick plate is above 10 inches, goes to 16, we're okay. But if it's below the 10 inches or at the 10 inches, we're going to have some sort of little filler or cap so that a cane or a crutch or something couldn't get down into that gap that's behind it. So keep that in mind. When we get to door closers, we always hear that American with Disabilities kind of talks about the amount of force it takes to open, but I will tell you, American with Disabilities also has the minimum amount of time that we have to close a door. So think about a person, again, with a disability going through the door. We don't want the door to try to close on them. Although delayed action is a feature that we can talk more about in future classes, but it is one of those scenarios where it will hold the door for a delayed period of time that you set on it before the door starts to close. So it's a great feature to have in senior living environments and delivery areas and doors that are prone to a lot of traffic by the public. Maybe that's a part of that. But minimally, when I set a door closer up, I have to have at least 5 seconds of closing time, maybe longer, from 90 degrees to 12 degrees. Fully closed is probably going to be about 7 seconds. So you can see that we need to really slow our door closers down. Now, the opening force comes into play, and most of us, that's what we've heard about. The problems with American with Disabilities is that our door closers are asked to now open easier, or our doors with closers are asked to open easier. It is defined as interior non-fire rated doors have to have 5 pounds or less of force. Exterior doors, under the national document, it just says reserved. California is one state that has chosen to apply an exterior force on their doors, which is 5 pounds. I will give you an update on this. In California, they figured out you can't get a door closed when it's only 5 pounds of force to open a door. Door closers are only about 70% efficient, so the most I'm going to get out of it is if I take 5 to open it, I'm only going to get 3.5 back to close it. Because of winds, building pressure, things of that sort, doors have become a problem in staying open. So even in California, everybody is kind of like just going, yeah, we're not expecting you to comply today. So it's been one of those things that's taken a while, but in California, they're at least backing away from it some in certain jurisdictions. And in fire doors, we usually want the door needs to close, it needs to last, but at a minimum, the authority having jurisdiction may request a particular one. And an example here is in Chicago, their fire door authority having jurisdiction for their fire doors has asked that you said that they achieve 8.5. Not always the case, but you try to do it. And this is the force gauge that we would tend to use. Now, we talked about automatic operators. There's high energy operators, there's low energy operators. High energy, you have to be ATM certified. It's American Association of Automatic Door Manufacturers, and it's a safety basically course on how to have activation and safety sensors and things of that sort. These doors swing at a high rate of speed, but at 40 pounds of force, they have to stop operating. But when they're moving at a relatively high rate of speed at 40 pounds of force, it could still displace you or knock you over. Low energy operators, we're really taking high energy operators and slowing them down, and for American with disabilities. And so the ANSI 156.19 is low energy. They can't open any quicker than 3 seconds, so they're slower in opening. They can't have any more than 15 pounds of force to stop them from operating. But we don't need any safeties unless we have what we call a non-knowing act. And a non-knowing act would be an overhead sensor where it's a presence sensor. And when you walk up, it just recognizes you're there and it would open the door. They are required to have safeties on them today. Now, they're usually plug and play and you can attach them to them, but you don't have to be ATM certified to do low energy operators. You can install them, you can work on them, you can adjust them. They do require, under the standards, that you check the safeties of these door openers or operators every day. So it means you're going to have to go out and walk in front of the door to make sure it's operating. So by law, are we required to use operators? The answer is no. They don't require us to do it. They just tell us what the minimum requirements are or the maximum, like the type of forces and things of that sort that we have to meet. How we do it is up to us. So automatic operators can usually solve the problem, but sometimes we can do it mechanically as well. Now, when we deal with the fire doors, we're still going to have to meet the requirements of NFPA 101, life safety, International Building Code, part of it, but also the ANSI, American with Disabilities. But now we have components that come into the opening. So critical components are, number one, you want to make sure that the openings are labeled. So we're going to look for a label on the frame. It's got to be legible. Label on the door. It's got to be legible. Hardware has to have some sort of stamping or legible signage, label, whatever it might be. And then we're going to have a closing mechanism to bring the door to the close and latch position. That's going to be a door closer or a spring hinge. Our hinges are an integral part. They have to be steel ball bearing type hinges to meet the requirements of fire. Our door closer is going to be listed, but it's only going to be listed as UL10C. As long as it doesn't have a combustible fluid on the inside, that's really the critical component that's a part of that. When we have doors that have fire ratings to them, if we have a door rated above an 1.5, or that would be a 3R door, it's required to have an overlapping astragal. And nobody's exempt from this. These are always going to be steel doors. But a lot of times people haven't figured out, how do I get the door to close correctly, where this door leaf closes, this door leaf here, the inactive, closes before this one, which the astragal is connected to. So what ends up happening is you'll then have to have some sort of coordinator on the opening to assure us that the first leaf closes, then the second leaf closes. And these are designed where that's exactly what they do. You can't time door closers to make one slower than the other, because somebody stands in the way of one, the other one will still continue on. A coordinator will not allow that door that cannot close before the inactive door closes. And so we want to make sure that we meet those requirements when we're in pairs of openings as it relates to those. If we have any sort of mechanical or electronic hold open features, we want to make sure that we release those to make sure that the door closes and latches. So we don't want to just go up and assume that this magnet on the wall will release when the fire alarm goes off, and we just pull it away and we check the door. We want to make sure that when the fire alarm goes off, that door closer is strong enough to pull that latch away from that armature, that coil and magnet and armature that are at the top of the door, because there's a thing called residual magnetism that can occur. So we want to make sure that it meets the requirements of be self-closing and self-latching. When it comes to smoke seals and gaskets, there's a couple of different ones. There's an adhesive ones that are out there, there's jam mounted ones, and then there's astragal mounted ones. I always like to tell people that you're really going to have to know what the intent of the door was. So often we see soundproofing and weather stripping that aren't necessarily for the gasketing purposes of smoke seals and gaskets. But we do have, because of some changes that we made for UL10C, which is a positive pressure fire test that we do, there are some requirements where, and this is where the bottom of the door doesn't require it for one section where the door is not a pressurized area, but in the other section it would be pressurized. So that's where it's there. But when we look at our fire doors and our openings, we're looking for labels. So in particular, the ones that have been approved for smoke seal and gasket will be listed, where this says listed smoke barrier door. This has an S rating here. This has an S rating over here. In addition to that, these labels will tell us what sort of hardware we can put on these doors. In other words, this door has been designed to accept, let's see, 1/2 inch throw, 3/4 inch throw, or fire exit hardware. So I can put a lock set on here, or I can put a fire exit hardware on here. If it doesn't say that the door is approved for fire exit hardware, we can't put fire exit hardware on the door. It's not been reinforced. It's not been designed like that. So the labels will tell you what hardware you can and can't put on it. Now, the positive pressure test is a new test that we started doing, when I say new, over 20 years ago. But it now simulates exactly what a fire test occur, or what a fire simulates in the field, where we're sucking air at the bottom portion of the door, but then we're allowing pressure or gases to go at the top portion of the door. What it did change is really our wood doors. And so today we have what we call category A and category B doors. Category A door will be an intermittence material that's part of the door construction. It's part of the edge and the top of the door. And when it gets hot, it expands and fills the gaps around the door. Category B is doors that will work with applied intermittence seals and gasket. And so you'll see it here. There's your category A door. This would be your category B door. Be careful with category A doors. If you go to cut them down, you could interfere with the intermittent seal. So it's something to be cautious about. Wood door companies have, through the Wood Door Manufacturers Association, they share a lot of information, but I will tell you specifically to go to the wood door companies for their information, because they're going to be more detailed about what they can and can't do. And lastly, but not least, we talk about security information. If you're doing delayed egress, there's security requirements. Not all areas allow for delayed egress. If you do have a delayed egress that's being allowed in your jurisdiction, it has to be tied to the fire alarm. You can't encounter more than one of these in exiting the building. So if I've already encountered a delayed egress, I can't encounter another one. Basically, it allows us to detain people. If you think about a library, there's a lot of books and it's a lot of artifacts that are in there, but we have to have all these additional exits that are required to get people out safely. But we don't want them using those doors just at any time in particular. So we're allowed to put delayed egress on those doors, forcing people to come back to the main entrance. But if there ever was an emergency, those doors would become our path of egress to get out of the building. When we start to do access control, In particular, and I'll just sum this up really quickly here, if we're using magnets at the top of the door, we have to make sure that we have an ability to interrupt that magnet's power in case that little logic board that's maybe in a controller could get confused. So we're going to have these redundancies that are built in. There's a lot of things we can do. One is we can put a switch in the exit hardware and have it manage that power or disrupt that power to the lock. And so that meets those requirements. But if I don't have something like that, I'm going to have a push to exit button on the door that will give me that release or the redundancy that's there. And it has to be held for at least 30 seconds when I push the button. There's mechanical locks that are out there. And then the ASHRA, which is the energy code requirements, you're going to notice that you're going to, depending on where you are in the country, you may see a change in this. We're going to start to see increased vestibule sizes for our facilities or our buildings, so that the whole point is they want, when you come in, they would like these entry doors to have an opportunity to close before these interior doors open. They're trying to control the HVAC within the facility so that we're not losing that energy as it relates. If you're in zones 3 through 8 and you're above four stories, it's going to apply to you there. And so you see, notice this is kind of the map that's there. In particular, this is something we're going to see more of. It's a relatively new information. You can go to ashra.org to find additional information. So, all right, we're at a question standpoint now. So, Justin, I'm going to turn this back to you for the next few minutes, and we'll see if we have any questions from the audience.
Well, I haven't seen any questions from anyone, but let me change our meeting options to allow folks to unmute their mics. And if you have any questions, please feel free to ask Bob anything that you have. Which, and Josh just came in with one. He says, when it comes to balcony doors above the first floor, I'm seeing these doors swing in. What's the policy on this?
Yes, so if the balcony door has an occupancy above a certain number, it depends on the jurisdiction and where it is. Like, we'll see this in a courtyard, and so we kind of treat the courtyard and the balcony the same way, depending on if that's the exterior of the building. But our path of egress really is back into the building, right? Our doors on our residential homes don't usually open out. They usually open in. And that's just because we're a resident and it's a little bit different of an occupancy. When we start to get into the public environments and you would have that balcony, the capacity of that balcony is, first off, we don't want somebody to be able to be locked out on the balcony. Second is, their path of egress out of the building is not off of the balcony, but back through those doors. So depending on the jurisdiction and the classification of the occupancy of the building, that's one of those questions to the authority having jurisdiction or the state building departments where you have to submit and ask what it is. We quite frequently see that with courtyards in a school where they'll have the building surrounds the courtyard, but students will have the ability to get into the courtyard. But what's interesting is those doors in the courtyard actually have to allow them to escape the courtyard and get out from the inside. There has been some playing with that where they can put access control on to do that, but it really is a jurisdiction by jurisdiction. So you would have to meet with our local code person or our person that works with specifications and find out how that would apply to your specific jurisdiction.
Great. I don't see anybody else asking questions. I do want to express, though, that we do have the mics unmuted. If you want to unmute your mic, ask Bob anything that you have. We'll allow 3 or 4 more minutes, and then we'll wrap things up.
So just as a couple of closing slides that are up there too for that, in our industry, when we look at an opening, it used to be that we were very blind or kind of, if you will, terminology where we'd only look at the product that we maybe manufactured or serviced. Today, with the companies the way they are, we all have all these particular products. So we look at the whole opening. And so whether it's door frame, hinges, exit device, door closer, lock set, mortise, cylindrical, you name it, we're involved with it, including the access control and the automatic operators. In certain cases, we even get into glass doors and partitions and walls of things of that sort. So if we can help in any way, reach out to Justin. We have people all across the country who are there to help provide these solutions and these reviews and, if you will, inspections or clarifications for customers in the field.